We are on homework 7.5 in the textbook, and we are starting with number 2. It says, consider a cubing function. Cube is to the third power, described by y equals x to the third. And then they give you a set domain, but that's not really going to matter here, okay, because all of the numbers, if you take a look, 36, negative 36, 0, all fit in that domain, so there's nothing fancy going on here. We are just solving for the function given what x equals, which just means you're going to plug it in. So for letter A, when x equals 36, you're going to plug that in for x, so x becomes 36, and really this is just practice on plugging this in the calculator. You're going to take 36, you got to raise it to the third, so our raised 2 is right here, and that's your answer. So y equals 46,656. Part B, negative 36. So we do need to be careful when we plug this into the calculator. Anytime you're going to try and raise a negative number to a power, you have to put it in parentheses. And we've talked about that before. So here when we do y equals negative 36 to the third power, we're going to get negative 46,656. For this particular one, because there's an odd exponent, I'm going to get the same answer whether I put parentheses or not. But we have talked in the past, if you do this with an even exponent, okay, and you don't put parentheses, it's going to give you a negative answer. In fact, if you don't put parentheses, it's always going to give you a negative answer because the negative doesn't factor in with the exponent. And we need it to because we are plugging in for x, and that whole value is being raised to the third. So we would need negative 36 inside parentheses. And if I raise this to an even, you can see it should be positive because you're going to have a negative times a negative times a negative times a negative, which will cancel out. Okay, so long story short, we need parentheses around that when we plug it in. And y equals 0 to the third power for part C. That's just going to be 0. Okay, next question was number 7. So sliding over to this graph, part A, determine the domain of the function. So domain has to do with your x values. What are all the possible x values? And you can't just look at the graph, okay, because the graph could go from, let's say, negative 10 to positive 10. That doesn't change the domain of this function. The domain of the function is where you see the line right there. So it goes from negative 5 to positive 5, and everything in between has a point on this line. There's no breaks, there's no gaps. Okay, so everything between negative 5 and 5 is part of your x value answers, which is your domain. So you're going to write that just like this. So x is greater than or equal to negative 5, and it's also less than or equal to positive 5. Part B, we're looking at the range of the function, so we're going from the lowest point to the highest point. If there's breaks, we have to show that. But everything from 0 up to 5 is part of this function. Don't say negative 2. None of this line goes below 0. Okay, so negative 2 is not part of the range. 6 is not part of the range. Okay, don't just look at the graph itself. You have to look at the function. The function is represented by the line. The lowest point is 0. The highest point is 5. And every point in between that has a value. Okay, so the lowest y value, y is greater than or equal to 0, and it is less than or equal to 5. Okay, number 8. Determine if the following statements always, sometimes, but not always, or never true. The graph of a function may contain both points 6, 5 and 6, 7. If you just thought about that on a graph for a second. 6, 5, and then 6, 7. Okay, you don't have to look at it on a graph, but the vertical line test will tell you that you're going to hit 2 points here. And so this is never. And the vertical line test is just showing you that you cannot have more than one point or more than one answer to your function with the same x value. And since both of these points have the same x value with different y values, that means this is not a function. So if I say, what's the value of the function when x is 6? You can't give me 2 answers. There can only be one answer if this is a function. All right, number 9. So which table does not describe a function? If you look at letter A, we have 3 different x values. so none of them are going to have more than one answer. That's good. 3 different x values, all the same, all the same. So we need to check these out. Letter D is fine because if I said, what is the value of the function, which basically is asking you what's y, when x is 6, you can only give me one answer, 6, which means it's a function. Letter C is the answer. It is not a function because if I ask you what's the value of the function, when x is 6, you would say, well, it could be 1, it could be 2, it could be 3. Okay, and that makes it not a function. It can only have one answer. Number 10. Graph at the right is of a function showing the distance walked by a hiker over time. Letter A, find the value of the function when x equals 2 p.m. So you're going to find 2 p.m. and follow it up. Now in the answer key, I found a mistake on this one. It said 2 miles, and if you look at 2 p.m., this is not at 2 miles. This is actually in between 2 and 3. So this would be 2.5 miles. So if the answer key confused you, hopefully that clears things up. Letter B, find the value of the function when x equals 3:30 p.m. 3:30 would be right between 3 and 4. Follow it up, that's at 5 miles. Letter C, find x for the function being 5.5 miles. So 5.5 miles, right between 5 and 6, is right between 4 and 5. So that's 430. And letter D, use inequalities to describe the domain and range. So domain is going to be with x, range is going to be with y. So let's start with domain. Everything between 0 and 5 on my x-axis has a value here. There's no breaks. So the domain is everything between 0 and 5. So I say greater than or equal to 0, less than or equal to 5. And actually, I need to be careful. If you take a look, this does not start at 0. So it's not going from 0 to 5, it's going from 1 to 5. So this would be incorrect. This has to be a 1. Okay, not every graph starts at 0, so you got to be careful. It goes from 1, has 2, 3, 4, and 5. So it's from 1 to 5. Y values does go to 0 and all the way up to 6. Everything in between is included. So greater than or equal to 0, less than or equal to 6. Okay, number 11, determine if the graph of ordered pairs is a function. You can do your vertical line test. If you draw a straight line through any of these x values, do you hit more than one point? And I do right here when x equals 3. So is this a function? My answer is no. Justify your answer. You can say something when x equals 3, y is 1 and 4. Okay, and that makes it not a function. You cannot have more than one possible y answer for any x. All right, and number 12, same idea. Is this a function? Vertical line test. Pretty much anywhere you go on here, vertical line test shows that this is not a function. And you can just pick any of these. I'm going to say when x equals 0, y is 3 and also negative 3, which means it's not a function. Okay, 13. This is the function that's graphed at the right. Letter A, true or false? 0 is in the range of this function. Okay, so range is talking about your y values. We got to get that straight. Domain is x, range is y. Okay, so basically it's asking you, does this line ever hit 0? Okay, and the answer here is false. It doesn't ask you to explain, but this line will never hit 0. It will get infinitely close to 0, but it will never actually hit 0. Letter B, what's the value of this function when x equals 0? So you go to where x is 0, and you follow it up. The value there is 5. Letter C, what's the domain of the function that's graphed? So what are all the possible x values? This line is going to go forever to the right, which means all these positive numbers are going to be part of our solution set. And while this is going to go up very steep, it is going to continue slowly going left, going left, going left. And if we extend this forever, it will actually hit every single negative value as well. No breaks here. Okay, decimals included, not just whole numbers. All right, so this is going to go forever into the positives, forever into the negatives. That covers every real number. So this is all real numbers for letter C. Letter D. What's the range of this function? Okay, so range is all the possible y values. So clearly this is never going to hit 0. So none of the negatives are part of the range, but it is going to go forever up. So all of these positive numbers, and it's going to get infinitely close to 0, but never actually hit 0. So everything bigger than 0 is going to be part of this. So you're going to say y is greater than 0. You can't say equal to, okay, just greater than 0 because it never actually hits 0. In letter E, suppose x can be any positive integer. Okay, integers are whole numbers, including 0, including negatives, but this specifically says a positive integer, so that eliminates the negatives and 0. So we're just talking about whole numbers that are positive, 1, 2, 3, 4. What's the greatest possible value of y? So y is going to continue to get less and less and less the farther we go into these positive integers. So the smallest positive integer is 1. Okay, and that's going to be the highest point on this function, which is at 4. All right, 14. So in 14 and 15, there's going to be a situation described. Tell which quantity you wish to be the input, which should be the output, and then sketch a reasonable graph. Okay, so I'm more concerned with the graph here than anything. We always want to put time on the bottom, and as time passes, see what's going on. So this is the amount of time, and then this is temperature. And we can put 15 right next to it. As time passes, we've got the height of the skydiver in 15. So you pour out your hot coffee. It's really hot. Initially, it's going to start losing its temperature very fast. It's not as hot as it was, not as hot as it was. Then at a certain point, it doesn't get ice cold real fast. It's going to maintain, it's going to maintain. It's going to slowly still lose its temperature. Okay, but it doesn't stay super hot for long, but it will stay warm in the middle for quite a while. It's not going to just become ice cold real fast. And then 15, the height of a skydiver, you might think, oh, he's going to drop. But when you first jump out of that airplane, you're actually, let's say you started here, you're going to be going the slowest you're possibly going to go. The fastest you're going to drop is at the end. The longer you're dropping, the faster it's getting. So my height's going to start to decrease slowly, slowly, and then it's going to go faster, 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 faster. And then eventually I'm just going to be falling out of the sky super fast. And my height eventually hits 0. Okay, 16. For 16 through 18, we're just looking at this graph. We want to find the range with this domain. So the domain is talking about all numbers greater than or equal to 1. So on my graph, here's 1. So for all numbers greater than or equal to 1, well, at 1, my y value, or my range, is at 5. And as I go to all the numbers greater than 1, it's going to go up, and it will continue up forever. So the smallest value in this domain from 1 higher, when x is greater than or equal to 1, the smallest number is 5, and everything that's bigger than 5 is included. So you would say y greater than or equal to 5. 17. So now our domain is from -6 to -2. So that's right here, -6 to -2. What are my possible y values? So the biggest y value I see is 2. The smallest y value I see in this range, in this domain right here, -6 to -2. The smallest y value is 0 right here. So it goes all the way from 0 up to 2. Everything in between is included, and there's nothing outside of that. So my range, my y values, is everything greater than or equal to 0, less than or equal to 2. 18. My domain when x is less than or equal to 0. So my domain starts right here. So it's at 4. My range goes down to 0, and then it goes up forever. So negative numbers are not included in the range when x is less than or equal to 0. It never goes down in the negatives. And basically, it's going to cover everything from 0 up. It covers these numbers in here twice, and that's okay because we're not hitting the same y value for the same x. Okay, but everything from 0 up, and this is going to go up forever, is included. So all the possible y values when x is less than 0 goes from 0 to infinity. So we're going to say when y is greater than or equal to 0. And 22 is my last one here. In China, most families are allowed to have only one child. This policy was implemented to reduce the population with the goal of reaching 700 million citizens by 2050. Suppose the 2005 population of 1.3 billion decreases by 1% each year. Okay, so first of all, when you decrease by 1%, you're taking 100% and you're minusing 1%. That means you're going to be at 99%, which is 0.99 after a year, and then you're going to have 1% less the next year, so 99% of that, then 99% of that. So when you take off 1%, you're at 99%. So write an expression for the population of China X years after 2005. So this goes back to B times G raised to the X. Okay, my beginning point is 1.3 billion, which looks like this. It's 1,300,000,000. This is where the 1.3 comes in. So it's 1,300,000,000. So that's my beginning point, and I'm timesing it by my growth factor of 0.99. And I'm raising that to the number of years. And then part B, actually answer the question, will the goal be met? Okay, so in 2005, this was the answer. So what we have to do is we have to plug in how many years it's been. So since 2005 to 2050, that's 45 years. So we're going to go ahead and plug in 45 years of taking 1% off of it and see where we stand. See if it's under the 700 million that we need. So 1,300,000,000 times 0.99 raised to the 45th. Okay, and we're given this answer right here. And if I go ahead and I put in my commas here, okay, this is my millions. I'm at 827 million by 2050, and I want it to be under 700 million. So I'm at 800 million. And so my answer here is no, I have not gotten under 700 million.